Welcome to Sundar's lecture. This is lecture number 68, and in this lecture we are going to see some numerical examples related to RL, RC transient networks. See what are all the topics we have seen in the previous class. See, we have seen this discharging of the capacitor, and we have seen that while discharging the capacitor, voltage and the current both will be dying down to zero exponentially, and then we have seen what is the steady state condition of inductor and capacitor. That means RC and RL circuit, what will be the steady state conditions. If it is inductor, then it will be short circuited, and if it is capacitor, we have seen here, and it will be now open circuited, right. This is what we have seen in the previous class, and now in this class we will take a problem. See, this is the given network. An voltage source is connected, and then an inductor, a resistor is connected. There is a switch, and that switch is connected with the 8 ohms resistor. And what is the given conditions? The circuit was in steady state before the switch was closed at t is equal to 0. Which means before closing the switch, this circuit was steady state, at steady state. Which means what is the condition they have given you? This voltage source, an inductor, a resistor is connected. This is connected for stipulated time, and that is what they have given it as the steady state condition, right. Then what they have given you, for t greater than this switch is closed, and for t greater than 0, the current I1 of t and I2 of t is given in some structure, and they are asked you to find what is the parameters given in the conditions, but which means the current expressions, right. So now see, first condition, if you see any problems like this, you try to solve this problem by the question. See, before switch is closed, this circuit is at steady state. Then you write it down before S closed. That is the first condition, right? Before S closed, this is not connected, and only this circuit is connected, and that too we have seen this is at steady state. And what happens to inductor? Inductor will be short circuited. That is what we have seen in the previous class. And what will be the circuit now? See, I have just drawn the diagram, and inductor will be now short circuited. This will be the circuit, right? And I have just taken it as I of 0. Why I am taking this as I of 0? Because my circuit is going to connect with another resistance after some time. So I am just taking this current will be now I of 0. What will be the I of 0 value now? So I of 0 is very simple. How will you find the I of 0? So it will be in this direction. So it will be 20 divided by 12. And what is this value now? If you simplify this, you will get 4.167 amperes. And now, before the switch is closed, the circuit will possess, or maybe this inductor will carry 4.167 amperes through that. That is the whole idea. And now, if the switch is closed, and what happens to the circuit? Maybe I will write after S closed. If S is closed, then this circuit will be 1 minute. This value, what is this value? Actually, this is wrong. What is the value of 20 divided by 12? It will be 1.67, right? It will be 1.67. I have just written it wrongly. I'm getting it as 1.67 amperes. And if S is closed, then the circuit will be, see, I have just drawn the diagram. After S is closed, now these two resistance will be connected in parallel, right? So I have just made it to R equivalent. So if you simplify this, you will get 4.8 ohms. Right now, they are asking you to find for time t greater than or equal to 0, what is the current I1 and I2. Let us find what is the value of I of t by using this circuit. Maybe we will get this I of t, and then we will you can easily find what is I1 of t and I2 of t with this circuit, right? So now, if this is the circuit, what will be the equation for current? And we have seen these kind of things already. What will be the I of t now? I of t will be is equal to E by R equivalent, maybe this resistance R equivalent plus A e power minus t by tau. That's all. This is the equation, right? This is what we have seen. See, I have not taken this as E by R equivalent minus E by R equivalent, because there we have seen it with C. We will go there so that you can easily understand. See here, charging the inductor. See, this is the expression, right? See, this is the expression while it is connected to this point, and then what is the value of this this current I of t? It will be E by R. Here it is E by R. Maybe there we have R equivalent, so I have just taken it to be R equivalent plus A e power minus R by L, because here the initial condition of the current through the inductor is 0. That is why we are getting this expression. But now we will not get like that, because I of 0 we know, right? Already we have seen what is I of 0. So now what we can do, we can substitute t is equal to 0. So substitute t is equal to 0, maybe take it as expression number 1 in 1, and what you will get, so it will be I of 0 will be is equal to R E by R equivalent plus A e power. See, if you put 0, it will be minus 0. This term will become now 1, right? This term will become now. And what is the I of 0 value? We know that it is 1.67. That should be is equal to E is 20 here, divided by R equivalent is 4.8 here, plus A. And if you get what is A will be is equal to 1.67 minus 20 divided by 4.8. And if you simplify this, I am getting A is equal to, I am getting it to be minus 2.5. That's all. That's all. Now you see, now I can substitute in this equation this A value. So I of t now, I of t will be is equal to, what is E here? It is 20 divided by what is R equivalent? It is 4.8. It is 4.8. A value it is 2.5. It is 2.5 e power minus t by tau here. What is tau? We have already seen, right? What is tau here? It is L by R. It is L by R, and it is inverse. What is L here? What is L here? It is 4 Henry divided by what is R here? R, it is 4.8. So if you substitute here, it will be 4.8 divided by 4, and tau will be is equal to, if you simplify this, you will get 1 by 1.2. And if you substitute in this expression, maybe I will get final answer as I of t can be written as, what is 20 divided by 4.8? I am just getting it to be 4.167 minus 2.5 e power minus this tau value, it will be inverse, right? So it will be 1.2 t. So this is the final expression for I of t. This is the final expression for I of t. Now I have found what is I of t, right? Now I know what is I of t. So it is simple to find what is the I1 of t and I2 of t. Why? So you know this one, and if you apply current division rule here, it is very easy, right? It will be very easy. How will you find I1 of t? I1 of t will be is equal to, if you want to find this one, it will be I of t into, what is the opposite resistor? It is 8 divided by what is the total resistor? It will be 20. And if you simplify this, I1 of t will be is equal to I of t into it is 0. I'm getting it as 0.4. And if you multiply this one with I of t, and I am just getting it as I of t will be is equal to, sorry, it is I1 of t. I1 of t is equal to, so I am just getting it as 1.67 minus 1 e power minus 1.2 t. And you see, you just compare this with this expression, and I can finally write what is A1. This is I1 of t, right? What is A1? A1 will be 1.67, and what is B1? B1 will be minus 1, and then what is K1? K1 already there is a minus, so it will be 1.2. Very simple, right? And we have found I1 of t. What is I2 of t? So I will take it to the new page. I will take it to the new page. So I2 of t, maybe I will write it down here. I2 of t will be is equal to I of t, total current, multiplication of 12 divided by 20, right? So it will be multiplication of 12 divided by 20. And if you substitute and you find this value, that it is very simple. So finally I will get I2 of t will be is equal to 2.5 minus 1.5 e power minus 1.2 t. You just substitute, it is very simple, right? You just multiply here, you will get the values very simply, right? So then what is a, you just compare this expression with this one, a2 b2 minus k2 t, right? So what you will get, a2 will be is equal to 2.5, and then b2 will be is equal to, that is plus, right? Here it is plus, so we are getting it in minus, so it will be minus 1.5, and then k2 will be is equal to 1.2, because here it is minus and there also it is minus, so this is the final answer. See, maybe they are asking you to find with the parameters, maybe they will ask you to find what is I1 of t, I2 of t. If they are asking you, then you can finally you can conclude with this expression and then with this expression, right? So this is how you need to solve a problem related to our L, this one. This is resistor and inductor problem, and then we will take now RC. Let it be R, L, C, everything comes under. Then you will have a equation, second order differential equation. Alright, we will take a problem now. So see, we have taken the problem now, and in this problem you see here we have inductor and we have capacitor, both in the same circuit. If you see any circuit like this with both inductor and capacitor, obviously you will get second order differential equation, and we need to solve the second order differential equation. Everything will be very easy because we have seen how to solve the differential equation by classical methods, right? So now what is the question given? See, the switch is closed at t is equal to 0. So this switch is closed. Before that, the above circuit was in steady state. See, this circuit, this switch is opened. When the switch is opened, this circuit is at steady state. This circuit alone, the inductor and the resistor with the voltage, it is at steady state. And then on the capacitor was uncharged. See, this capacitor was uncharged while this switch is open, and that is also they have given you. And then for t greater than 0, so after switch closed, the current I of t and the voltage V of t is expressed in this, and we need to find all these parameters in the given expression. See, one thing at the steady state, let it be the, I have already told you. So before S closed, you take this as the example. Now you have to solve these kind of problems like this, because before closing this switch you can see what is the initial condition of the inductor and capacitors. That is why they are giving you the problems with the initial conditions. Without initial conditions it will be very easy to solve. That is why they are giving you the problems like this anyhow. So before S is closed, this circuit is at steady state, right? So if I draw the diagram, see, see, I have just drawn the diagram. Inductor will be short circuited at steady state, right? This is at steady state. I have already told you, right? So at steady state, inductor will be short circuited, and this current I am just taking it to be I of 0, because we know, right? This is initial condition. So I of 0 will be is equal to, if I find this one, this will be 60 divided by 600, and then if I cancel out, it will be 0.1 amperes. That is the given. And you see the another condition. What is the other condition? Where it is, see, this one at steady state and the capacitor was uncharged. And if capacitor was uncharged, then V of 0 will be 0. That is given. That is given. See, if it is second order differential equation, then you need two initial conditions. You would have studied these kind of things in the mathematics, but without any real-time examples. But now we are entering into real-time examples. See, this is the given initial condition. So now after S is closed, I will write it out. F's closed, after S closed, then what happens to this circuit? That I'm going to draw now. See, this is the diagram now. If S is closed, then the circuit will be like this, right? So here it is given I of t and V of t, they have given you, but what I will do, I am just assuming it to be I1 of t, and this I am just taking it to be I2 of t. So you see, if I want to find what is the value of I of t, it is now easy, right? So I of t will be is equal to what? Simply I can write it as I1 of t plus I2 of t by using the Kirchhoff's current law. It is very simple. This is coming in, these two are going away, so I can write it like this. So, and even further, if I write this one, what is I1 of t? The voltage in this across this branch will be V of t, and this is the resistance, right? So it will be V of t divided by 600, that is I1 of t, plus what is I2 of t? It is going in the capacitor, right? So what it will be now? So it will be C dV by dt. What is C here? It is 1 divided by 6600. C dV, maybe I will write d of t, okay, anyhow. This will be the expression. Make this expression as 1. It is very simple, right? We have just written this expression by using the given conditions. And if I want to write the KVL expression for this loop, I will just write it down. Maybe KVL. By KVL, see, I am starting from this point, I will go in this way. What I will get, maybe this one or this one, anything it may be. So what I will get, it is from minus to plus I am going, so it will be 60 minus, see what is this voltage across the inductor, it will be L di by dt, right? So what is L here? It is 220 into di by dt, and then what is this one? So this is plus minus, so I am just traveling from plus to minus, so it will be minus V of t, that should be is equal to 0. This is the expression, and you can substitute this I of t into this expression, right? Because I know what is I of t, and I can substitute here, or maybe I of t can be substituted in this expression to get everything. So this is the KVL expression, right? And you just take this expression as number 2. See, I will take this to the next page, this I of t and this expression, these two expressions. See, I have just brought this expression to the next page. See, what I can do, now I can substitute 1 into, I'm going to substitute this whole into this I of t. So what I will get, so this will be now 60 minus 220 d by dt of this I of t. I have to write this is, no, I am not going to write this as V of t. I will write it as V. So V divided by, it will be 600 plus 1 divided by 6600 dV by dt, and it will be there. So this minus V will be there, that should be is equal to 0. And if I simplify this further, what I will get, so 60 minus maybe d by dt of 200 V divided by 600 plus, sorry, this will be 220, right? So this will be 220 divided by 6600 dV by dt, and minus V, that should be is equal to 0. And if you simplify and you write down this, if you write down this expression, see, you are getting an expression like this. Just I have simplified, and if you multiply inside, what I will get, so 60 minus maybe it will be 11 by 30 dV by dt, I have just multiplied, and then it will be again minus 11 by 330, it is now d square V by dt square. This is second order differential equation, right? This is V of t, that should be is equal to 0. And if I rearrange this one, what I will get, finally I will get like this. If I bring everything to the other side, it will be 11 by 330 d square V by dt square, and then plus 11 by 30 dv by dt plus v, and that should be is equal to 60. See, this is the expression now, and we know that it has to be d square v by dt square, right? So if I divide everything with 330 by 11, 330 by 11, what I will get, I will just write it down here. So see, I have just uh, multiplied it by 330 by 11 on the both sides. So I am getting this expression. Now it is very simple. See what we will do now. We are going to get the expression of v of t using solving the differential equation by classical method. So for that we need to get what is the characteristics equation. So it will be d square plus 11 plus 30, and that should be is equal to 0, and the first characteristics equation will be m1, that should be is equal to 5, and m2 that should be is equal to 6, right? If you simplify this and you get all these kind of things, you will get this one. And we have already seen, right, how to find v of t now can be written as a e power minus m1t plus b e power minus m2t plus we need to find what is k1 of x. What is k1 of x? K1 of x will be now, it is 1800 plus k2 of x dot. What is x dot? X dot will be 0 because this is constant, right? So, and if you multiply the both things and you just take it to k1, I have already see, we have seen these kind of things already. Please go through my previous lectures to find how to solve the second order differential equation. You will get an idea. So finally we can write it as what, you should know what is k1, right? So this is the solution due to natural function, and then it will be forcing function. So this is vf. So this alone should satisfy this differential equation, and if you substitute k here, maybe d square by dt square into k1, and then plus 11 d by dt into k1 plus 30 into k1, and that should be is equal to 1800. See, if you differentiate constant, you will get 0, you will get 0. So 30 k1 by is equal to 1800, and if you simplify further and put 30 here, you will get k1 is equal to 60. That's all, right? So k1 is equal to 60, and finally what is the value of v of t? V of t can be written as, we will write this as first one, 60 plus a e power minus, what is m1? It is 5, it is 5t plus b e power minus 60. This expression, maybe you take it down to number 3. Now we have found what is the value of v of t, and you see, we know what is the initial condition. What is v of 0? V of 0 is 0, right? That is given already. V of 0 is 0, that is given already. So if you substitute v of 0, it is equal to 0, maybe that should be is equal to 60 plus, if you substitute, this will become now 0 will be 1, here it will be 1. So a plus b, and see what is the value of a plus b now. A plus b, that should be is equal to minus 60. You bring this one to that side. So this is equation number 4. And you see, if you know what is v of t, you substitute here, you will get I of t. Very simple, right? So I will copy down both and put it in the next page. And now you see, I have just taken both expressions, and now you substitute this v of t here, what you will get. So I of t will be is equal to, this is v of t, right? So it will be now 60 divided by 600 plus 60, maybe this expression, right? So 6 v of t, I'm just substituting. So it will be a e power minus 5t divided by 600 plus b e power minus 60 divided by 600. So I am just going fast, try to be with me. So this will be now plus 1 by 6600 into d by dt of this whole expression. So it will be 60 plus a e power minus 5t plus b e power minus 6t. You will get this expression. So if I simplify this, what I will get? So this will be now, I will just write it down. It will be 0.1 plus a by 600 e power minus 5t plus b by 600 e power minus 6t plus this value, it will be hold, this will be whole. So if you differentiate this, this will be 0, and this value will be minus 5a e power minus 5t, and then it will be minus 6b e power minus 6t, right? This will be like this. And if you get inside, I of t will be is equal to 0.1 plus a by 600 e power minus 5t plus b by 600 e power minus 6t, and if you multiply this inside, it will be minus 5 by 6600 a e power minus 5t, and then it will be minus 6 divided by 6600 b e power minus 60. And this is the expression, and it is very simple. Why? Because I am going to substitute I of 0, right? What is the I value of I of 0 that we have seen in the initial condition? It will be 0.1, right? So it will be 0.1, it will be 0.1, and this 0.1 will be is equal to 0.1. See what happens to this value. This is 1, this is 1, because if you put 0, it will be 1, right? So a by 600, that will be there, and plus b by 600, because this value becomes 1, and you see this also becomes 1, right? Becomes 1, and you will get minus 5 by 6600, and then minus 6 by maybe this value will be a, and if you put 0 here, you will get minus 6 by 6600 b. See, if you finally simplify this, what is the expression you are getting? And now you see, I have just taken, this is the final expression. Maybe I will take it up. See, this is the expression I am getting from here. So now you see, you have a b as the unknown, and if you simplify these two, you will get the values of a and then b. So I am getting a will be is equal to 300, and b, which is equal to minus 360. This is the value I am getting for a and b. Now I can substitute in this expression, right? So what is now I of t? So sorry, it is v of t. So now what is v of t? V of t will be is equal to 660 plus 300 e power minus 5t, and then minus 360 e power minus 60. So this is the expression for v of t. This is for v of t. And if you put this expression here in I of t, you will get I of t as, just substitute this expression here and you simplify, you will get this one. And if you substitute, obviously you will get this value. Just put this expression in 1, you will get this expression. Now it is very simple, right? You can directly write what is the value of ai, current expression. It is 0.1. See, I am just comparing here. That is the given, right? This one, these two, I am just comparing and I am just writing it down. So it will be a1 will be this value, and then bi will be 0.27, and then ci will be minus 0.27, and then av will be 60, and then bv will be 300, and cv will be minus 360. So these are all the parameters that was asked in the question. We have found all the values, right? So you try to solve number of problems. Maybe I have just skipped this expression because I have done already this one. So it is very easy to put this v of t in this expression to get these values, and this is how you need to simplify the transient network problems, right? So you go through all these problems. We will take some more problems in the next class so that you will get a clarity. So we will see in the next class. Thank you.